So, so yes, where are the GLP-1 receptors? So pancreatic beta cells, central nervous system, stomach, small intestine, heart, fat, kidney, the enteric nervous system, that's your gut nervous system, muscles, bone, liver, all over. And so the body has a way of tasting from the mouth all the way through to the anus, and that's either the taste bud or the epithelium. So the body is constantly tasting, constantly sampling the environment, and that's important for ingestion to stop us from eating things that are poisonous or bad for us, digestion, and also absorption. So we talked about before that taste receptors, type 1 are for sweet and umami, type 2 are for bitter, and those are present and stimulated and produce the GLP-1. The GLP-1 receptors in the brain are found primarily in the frontal lobe, and then less so in the prefrontal and parietal lobes. The midbrain is less. The hippocampus and hypothalamus is even less. Thalamus and pons is even less, and medulla and medial-frontal cortex are less. There are none in the cerebellum and the orbital frontal sections of the brain. No receptors. So it kind of makes sense that the brain receptors for GLP are such, because they correspond to the reward centers, the motivation centers, the decision centers, the memory centers, the appetite centers, and the metabolism centers in the brain. And that is the job of GLP-1. So the hypothalamus is the part of the brain that is the most important for feeding. And so that's one of the areas that has more receptors since GLP-1, because GLP-1 is about feeding and reward, and that's part of what the hypothalamus does. What else does GLP-1 do? So we talked about how it's neuroprotective. So in a study of GLP-1 receptor deficiency, they found that there was an increase of neurodegeneration and seizures. And if the GLP-1 receptors were overexpressed, that improved cognition and was neuroprotective. So GLP-1 in proper dosing is fantastic. GLP-1 also regulates the neurotransmitters, serotonin, dopamine, GABA, and glutamate naturally. In the heart, GLP-1 receptors are related to the pacemaker, and the GLP-1 can decrease inflammation and ischemic injury, but also increase heart rate and affect the left ventricular function. So you're going to see with GLP-1, there's always a balance between what it does, helpful and hurtful. GLP-1 decreases inflammation in general. It causes smooth muscle proliferation and platelet aggregation. It decreases smooth muscle proliferation, and it decreases clotting. It increases vasodilation, improves endothelial function, stabilizes plaques, and improves blood flow. In GLP-1 has receptors in the kidney also, and it seems like it's related through the sodium sensing mechanism, so that when you eat, the gut senses the sodium that you're taking in, and Then the kidney GLP-1 receptors are activated. You'll pee out excess sodium. GLP-1 will cause increased renal perfusion and oxygenation and will decrease angiotensin II, causing vasodilation and decreasing blood pressure. In the liver, GLP-1 has a greater influence than anywhere else, any other organ in the body. It will cause the glycogen synthesis, that's the stored form of sugar or fuel. It will decrease glucose production and decreases fatty liver, and as well as VLDL form of cholesterol.